This is example 2.17 of vector algebra chapter 2. So there are 4 sums similar to this: cos a minus b, cos a plus b, sin a minus b, and sin a plus b. All of them are similar. So the main thing that you need to do to prove this is draw a perfect diagram. Okay, that's what we are going to do first. So the sum is to prove that cos of a minus b is cos a cos b plus sin a sin b using vector method. Okay, so first thing is we are going to draw a circle. Okay, in the circle let's put the x-axis and the y-axis. This is x and this is y. Okay, and the center point is O. Now in this circle mark 2 points P and Q. Okay, so if I am going to draw a line to join the origin, it would be like this. Okay, now I am going to extend OP to meet x-axis at M. I am going to extend OQ to meet the x-axis at N. Okay, now you will notice there are two angles. Angle POX, which is the big angle, I am going to mark it as A. And the next angle is the small angle QOX, which I am going to mark as B, angle B. Okay, so if POX is angle A, I'll write it down here. Angle POX is equal to angle A. Okay, and angle QOX is equal to angle B. Suppose I want to find out this angle, the one I am marking in yellow, which is angle POQ. What will that be? Right? That would be the big angle, that is POX, minus the small angle QX, right? So POQ, the yellow part, is nothing but POX minus angle QOX. So we can write this as A minus B. Angle POQ is nothing but A minus B. Okay, take this deduction and have it just as it is. Now the next thing that we have to do is to find the coordinates of P and Q. Okay, you would have seen in your textbooks, right? P or the coordinates will be cos A and sin A. But why it is cos A comma sin A? That's because if you take angle A, right, the big angle here, if you take this big, if you treat it as a right angle triangle, what happens is, for angle A, OM, right, becomes the adjacent side. The OM is the x-axis, right? That's why cos A is the, cos A or the formula adjacent by hypotenuse, right? So that's why you have cos A as, this is one crooked or crude way of remembering it. Cos A is the adjacent side. Okay, so that's why the P coordinate, x coordinate is cos A, and y sin A, because sin theta is nothing but opposite by hypotenuse. So if you see for angle A, this is the opposite side, right? PM becomes the opposite side. It is parallel to the y axis, so it becomes a y coordinate. Similarly for Q, the point will be cos B comma sin B. Okay, I hope this is clear. So once this diagram is drawn neatly, I haven't drawn it neatly, but once you draw it neatly, for the diagram itself you will be given a couple of marks. So we'll write the coordinates of P and Q. So P or the coordinates is cos A comma sin A, and Q or the coordinates are cos B comma sin B. Now it becomes very easy. So now you have to make a few assumptions. Let I vector and j vector be the, I and j be the unit vectors along x-axis and y-axis respectively. Okay, therefore if I now have to find out OP dash, right, OP it will be nothing but, if I take OPM triangle, OP is nothing but OM plus MP, right? OM can be written as, OM is nothing but the x coordinate, and here the x coordinate is cos A, and you also know that unit vector is I vector for the x axis, so it becomes cos A I vector, right? And what is MP? MP is nothing but the y coordinate, right? It's parallel to y axis, so it becomes sin A, and it is along the y axis, so it is j vector, right? This is one equation that we've got. Similarly, write the next equation, right? OQ is equal to, so OQ is nothing but ON plus NQ, which can be written as cos B, again ON is on the x-axis, so I vector plus sin B j vector. Okay, so we have got OP and OQ, two values. Now let us do the dot product of OP and OQ. OP dot OQ is nothing but, what is the value here? Cos, so the dot product of OP dot OQ will be cos AI sin AJ dot cos BI sin BJ. So obviously when you multiply, the answer you will get is this dot this dot this, right? So cos A cos B, right, plus sin A sin B. Okay, got here sin B. Let's mark this as equation 1. So now we also know that OP dot OQ can also be written as mod OP vector mod OQ vector into cos of A minus B, right? So this is nothing but, this you can mark it as equation 2. Okay, so from 1 and 2 what do we get? Well, so this I can, the second equation I can write it as, so since these two are unit vectors, I can straight away write it as A minus B, right? So let's mark this equation as 2. So from 1 and 2, so from this equation and this equation, I can say cos of A minus B is equal to cos A cos B plus sin A sin B. It is what we have to prove. So it is proved. Okay. So the very important thing in the sum is mainly the diagram, understanding the diagram, and from there, if it's cos A minus B is what you have to prove, you have to take the dot product and prove it.